Okay, so we're on 119 looking at homework. So 1 to 6 asks you, is this a function? And so the technical definition of function had to do with ordered pairs and one of the coordinates being the same while the other coordinates were different, and it was kind of hard to think that through. So from a graphing perspective, I introduced you to a tool that you could use for these first 6. What was the tool called for the first 6?
Vertical line test.
Vertical line test. So what we have to do is imagine vertical lines being drawn through different portions of the graph. If you're touching never, is that good or bad? Are we in the running for a yes, or are we saying no if it doesn't touch in your imaginary spot?
No.
That's okay. What if it touches 1 point?
This is fine.
We're still good. When are we saying no?
If it touches it, 2.
2 or more.
I marked the time on the board.
Okay.
Right next to the thing where we were at.
Very good.
For the next time. Thanks.
So if we get 2 or more touches, we're going to say no. If you get a single touch or a non-touch, you're good to say yes. So 1 to 6, there's 6 of them. We did all 6 of these. Who wins the contest? Yeses? Nos? Tied 3-3?
Yes.
Yeses win. What's the score?
4-2.
4-2 is correct score. Which 2 are the nos?
3 and 4.
3 and 4, I agree. Does anybody need help understanding why 3 and 4 were the no's on the double and triple touching? The other ones are yeses on single or non-touching. The hardest one is maybe 5. If there's the hole in the graph means that there's nothing there. So if you have a hole above a regular dot, how many touches is this? Is this a single or a double touch?
Single.
That's a single touch because no one's home at the hole. 7 to 16, we started to just do the evens to save yourself some bother. 7 to 16 even, what you're going to do is take the number in parentheses and plug it in for x and just see what happens. So I know we didn't do like number 9, okay, but if I wanted to do number 9 to just explain what the section's about, for part A with a 0, I would need to take 5 times 0 squared plus 4 times 0. Math that up, see what happens. To do 9B, I would take negative 1 squared times 5. Add that to whatever 4 times negative 1 is. To do 9C, I would do 3 squared times 5. Add that to what 4 times 3 is. For D, I would just replace the x with a t and write 5t squared plus 4t. But there's a for example. I don't necessarily want to read all of these answers, but 7 through 16, does anybody need some guidance as to what it was you were supposed to do, plug in to get a whole bunch of stuff?
So I know what I was supposed to do, but I don't know like what I was supposed to do. So I was supposed to do 7 and 16.
We're doing even, so yeah, 7 to 16, we just did 8, 10, 12, 14, 16.
I was like,
Okay, if you did all of them, it didn't hurt, you got extra practice. If you did the odd, so that stinks, because you did the right amount of stuff and it didn't do the right thing. Anything to 16, helpers? 17 to 24, we're back to just doing everything again. So 17 to 24, some of these you just get to say all real numbers. Okay, the domain has to do with the x's that you could plug in. Some of these have unlimited plug-in abilities. How many have unlimited plug-in abilities and you get to say all real numbers?
17.
There are 3 of them, yes. So there's 3 that you'd say all real numbers. All of the rest of them, the other 5, they break the same rule. What's the rule that the other 5 could possibly break and we need to shield that from happening? What's a math rule that's breakable by the other 5?
isn't it like you can't have the same thing?
No, that was 1 to 6. On this group, there's another. There's certain numbers we can't put in because they just blow up the
Oh,
world.
you can't have that.
Yeah, we're not allowed to have 0 on the bottom. So there's 5 answers that you're going to write. X is not allowed to equal somebody. So let's look at 20. For 20, who would x not be allowed to equal? 3. Okay, so for 20, your answer is not 3. Okay, if I say to you, what is the domain? And you say 3. What you're telling me is that 3 is the only number you are able to put in. What you want to tell me is that x is not supposed to be 3. Okay? Everything other than 3 is good. 3 is the bad boy number. They're not asking you to list bad boy numbers where you put 3. They're asking you to list good boy numbers. So say everybody other than 3 is what you're trying to list. 23, the bottom's a little different. How many numbers would go in your list for 23? 3, because there's 3 portions to the bottom. 22 would have how many? 2, because there's 2 portions on the bottom. Some of the other ones only had 1 number, like 20 had 1 number. But 17 to 24, 3 of the answers are going to say all real numbers are good. Other 5 of the answers will say x not allowed to equal, and then you'll list off 1 or 2 or 3 numbers that are bad boy numbers. Anybody need guidance up to 24 on what was happening? Okay, 25, when we get into our absolute value graphs, what shape are all the graphs going to be from 25 to 30 for the absolute values? They're all V's. Okay, so 25 won't be a basic V. It got moved a square. Where did it move? It moved to the right. 1 square is correct for 25. 26 is a weird V. It's not a regular V. It's a sideways V. It also moved a square down, is true. 27 is the weirdest of all. The left side of the V does a funny thing. The right side of the V does like a normal V kind of thing. What happened to the left side of your V? Anybody have a weird left side of your V? Because it didn't go like this. The right side did this. The left side, it is, I wouldn't even say it's shorter. Anybody left side of the V, a weird thing? We may not have scored on that. The right side of the V looks like the right side of a V. The left side of a V is not going like
Is
this.
it just one?
It just completely flattens out. So the left side should just sit on the negative x-axis. It's just completely flat, horizontal. So you get something that looked about like this. 28, is it more like 26 sideways, or is it more like 25, a regular V? It's more like 26. Just instead of going down a square, where did this one go? Yeah, it went left a square. Is 29 more like 25 or more like the 26, 28? More like 25. How is 29 different than 25? Yeah, it's like sort of flattened out. It doesn't get as steep as fast. It's like a flattened out version. 30, regular V or sideways? Regular V. Is it steeper than the other ones? Less steep? Equally steep?
A little steeper.
I'd go with a little steeper. It's going to be a little bit skinnier, steeper. It's also shoved down 2 squares. So the bottom of the V is down 2 below the origin. To do those, I'd want to see a table of 5. I'd want to see a graph. I can do some of that if people are stuck on the V's. Does anybody need some help graphing some V's? Okay, 31, 32, 33 is a bunch of steps. So 31, the steps should just be going sideways. Each step fills 1 square. 32, 33 are the ones that I called Spider-Man steps, or I said they look kind of like lollipops when you draw the like open circles at the top. They look a little bit like lollipop things, or little barbells. If you're a weightlifter, maybe you could make that analogy. But 32, you're filling 1 square of straight up and downness. 31, you're filling a square of straight acrossness. 32 and 33 actually are the same. So if you did 32 and then 33 was its identical twin, that's true. That they are, those two are identical twin graphs. Anybody need guidance on the steps or the Spider-Man steps or anything about the page 119 homework? 32. So 32, we have x equals y with those weird brackets minus 1. So first most important thing to remember is if I put whole numbers into my table, what does this weird little brackety guy do if I give it whole numbers? Stays the same. It does actually nothing. So if it's x equals, am I going to pick my 0, 1, 2 for x or my 0, 1, 2 for y? 1. So 0, 1, 2 for y. Whichever letter's alone, pick 0, 1, 2 for the other letter. So 0 stays the same and subtracts 1, I got negative 1. 1 stays the same, subtracts 1, I got 0. 2 stays the same, subtracts 1, I got 1 out of that. You with that? So where anybody is negative 1, 0? Left a square, 0, 1. Up a square, 1, 2. Right 1 up 2. So we've got something like that. You good with that? Then I'm going to just suggest you memorize the fact that when you see these brackets, it's just going to make steps. The steps always fill a single square. It's just a question of, am I going to fill a square across, or am I going to fill a square going straight up? If it's x equals, anybody confident whether I'm stepping to the right or going Spider-Man? Straight up. Anytime it's x equals, just fill a square up and put an open dot at the top. Fill a square up, open dot at the top, fill a square up, open dot at the top. How many of these would there be in the real world? Infinite amount. They're going to go forever that way and that way. If you graph like 3 of them, that's good enough for me. I got the point of what you're doing. Is that okay? If this had reversed the y and the x and it was y equals, I'd have just filled those little steps the horizontal direction. Anybody else 121, 119, 120, those pages, anything that you're not sure how to manage from yesterday? So if you're done, send those down, make sure your name and then page 119 is on there. If you're not done, I'm not going to list names while we're recording. If you're like halfway, let's talk about that in a couple minutes. And then we'll just dig into 3-4 notes. 3-4 is the last lesson for a couple days. So what's going on for tomorrow? We'll just go over some homework. What's going on then for Thursday, because today is Tuesday. Thursday there will be a sheet due. I'll give you the sheet today. You can work ahead if you want to. Thursday we'll review the sheet. Friday we'll take a quiz, and then next week we'll start getting new lessons again. The whole rest of this week will be a homework day, a sheet day, and then a quiz day. So 3-4 is going to talk to you about linear equations. It's sort of obvious from the title, I think, what a linear equation means. It's an equation that if you graph it, you get a line. Hence the term linear. It starts with the root word line. Ruling on this, if you eyeball an equation, here's 5 of them that we'll eyeball in a second. When you eyeball an equation and you want to know, is the graph going to be a line? Here's the rules. You can only have first powers of x and y. What happened when we hit second power in this chapter? We got u's. You can't have products of variables with other variables, where product means things are multiplying. So if a variable multiplies another variable, that is not linear. That's going to be something else that we'll talk about later in the year. It's a shape called a hyperbola. You can't have variables on the bottom. If you have variables on the bottom, that's going to be a no-go for being linear. That's a shape you won't probably see till like trig. I don't think we have any of those in the Algebra 2 book this year. So here's 5 equations. Some of them, yes, they're linear. Some of them, no, they're not linear. We'll open up the floor for people to judge that. The first bit of homework, they'll just give you a bunch of these and say, are they linear, yes or no? You don't have to graph them. They just want to know, if you graph them, would you expect a line, or is this some other kind of a shape? Thought on any of these? Yes, no, there's no maybe so's. One is or isn't? Is. One is linear. Yes, it obeyed those rules. It was first powers x and y. There's no variables multiplying other variables. There's no variables on the bottom. One is linear. That's almost identical to when we started this chapter, I threw up x plus y equals 5. And we came up with all these ordered pairs, like 10 of them, and then I graphed and it was a straight line. That's the same style of equation as what we opened the chapter with. Other thoughts from other people? You're banished. You already answered one. Somebody else weigh in. Good news, bad news. You saying something? 3 is a no what? Variables on the bottom. So 3 is a no. Not allowed to have variables on the bottom. That's a true story. Third customer? 4 is a no. Why is 4 a no? You're not allowed powers on the variables. That's true. So 2 more people to weigh in on 2 or 5. Go ahead.
Well, Nicole said no, so I'll say it's no.
For which one? 5. Is that what you're weighing in on? That's not what you said. You're misquoted. What did you say? You said 5 is yes. I agree with 5 as a yes. Variables are allowed to multiply other numbers. Variables aren't allowed to multiply other variables. So 5 does pass the test. So that leaves us with 2.
I'm just gonna ask, are these in the books? Like the ones that you have?
No, I just made these up myself.
2 is a no.
Why is 2 a no?
Because it's variables multiplying each other.
Variables not allowed to multiply other variables. So homework will be on 127 if you want to peek at the homework while I'm talking about the lesson. 1 to 10 is what we just accomplished. 1 to 10 says, are these linear? Yes or no? If you say no, you have to say why. So a question like this, we would just say yes. A question like this, we'd say no, no powers. This we'd say no, variables can't multiply other variables. Here we'd say no, variables can't be on the bottom. This, you could just simply say yes. Question about how to manage yes or no, this is or isn't linear. Second group of homework will ask you to put things into standard form. So if we dig through our Algebra 1 and geometry memories, maybe you remember standard form and maybe you don't. So if you don't, or if you're not sure, here's what standard form is about. Standard form is that you get x and y on the same side. So it should look like something x on the same side as something y, and if it ends up subtracting instead of add, so be it. But some x's, adding or subtracting some y's to equal a third number, that's what standard form is supposed to be. Some books will make you do integers. So if you have an Algebra 1 memory of trying to bump fractions off because the book wasn't allowing you fractions, our Algebra 1 book was of that opinion that they did not like fractions. Our book, I don't know what their opinion is, but they don't give you any fractions, so it doesn't really matter. If you get x and y on the same side, and you get the number out of there, I'm good for standard form. And I'm going to see if our book actually believes what I'm saying. No, our book is going to claim that I'm a liar. This book and the Algebra 1 book are, they're different. The Algebra 1 book was saying x and y on the side, number out of the way. The Algebra 2 book is saying get everybody to the same side. I'm not saying that. Okay, so we're going to go with what I'm saying, which is what the Algebra 1 book is saying. Get x and y on the side, get the number out of there. I'm going to call that standard form, and I don't care in here if those are made integers, even though the Algebra 1 book did. So what is the official answer to that? I don't know, because you're hearing from 3 people with 3 different opinions. So what we're going to do is get x and y on the same side, get the number out of there. Question about that idea of what we're going to try to do. So this one, is this in standard form or no? No. So if we rework this, who's got to travel? I wouldn't make the 7 travel. I'd just make the 4y travel. Leave 3x, get 4y to be its friend. How's that gonna look if we do some opposites to get this stuff manipulated?
Be minus 4y.
It would be a minus 4y, and it would equal still 7. Question about what I did there to manipulate that one? If you look in the back of the book isn't going to say that because I'm telling you a different thing than what the book's telling you. For this one, what do you think about standard form there? There's no y. So what do you think?
It was already in it.
I'm going to say good enough. The book is going to disagree with me. What do you think the book might want to do about y's?
0, 1.
Put a 0 y. Is that wrong? No, I think that's right. I think this is in standard form, but I'm going to say this is in standard form too. And the book would be mad at me, but those people are probably not alive anymore who wrote the book anyway, so what difference does it make? I'm going to say that's already in standard form. If you look in the back and they're doing stuff with 0 x's or 0 y's just to have the letter there, okay, that's fine. I don't object to that, but I don't require that of you. Question about standard form, x and y go to a side, the other stuff I'm going to ship out. That takes us to 20. 21 through like 42, it says graph. So there's 2 ways that we can graph. What have we been doing up till now to graph our graphs? What do I make you show on your homework every day?
The X and the Y.
What's it called? T for, yeah, I know. It's a thing, it looks like this.
Just a graph. Oh, X minus something?
Yeah, that XY thing, this thing. What is that thing called? It's a 5-letter word. Table is correct. So we could continue to make a table. Okay, anytime you don't know how to graph something, if you want to make an XY table, that's fine. I'm going to introduce a second tool to your toolbox for this year, which is to find a thing called intercepts. Does anybody remember what the intercepts are? It's where we touch the x-axis or the y-axis. What's going to be true about the ordered pairs of intercepts? One of them is going to be 0. So sometimes I think it's a lot easier to find the intercepts than it is to make a table. Is it ever wrong to make a table? No. Okay, but sometimes I think it's easier to find intercepts. So if you want to make a note of what I'm about to say, I'm not writing this down, but you could write it down if you don't trust yourself to remember it. I make intercepts if the equation is in standard form and the x and y numbers, the coefficients, can divide into the other side. So I would not do intercepts on this because 3 and 4 can't go into 7. Okay, I would just do something here with a table. This one, would I do intercepts? I absolutely would. It's in standard form. 4 and 5 can divide into 20, so I would find myself some intercepts. Again, as always, the first number represents the variable x. So if x is 0, I'm just going to cover up the x part of this with my hand, because if I plug 0 in for x, it's just going to completely eliminate that. So when x is 0, cover up the xiness, and then do an opposite to figure out y. Y would be 4. Here, y is 0, so I'm going to cover up the y-ness of this. If I cover up the y part and just solve the remaining pieces for x, x would be 5. Most of our lines up till now, I've always encouraged you to do 3, find 3 points. Why do I encourage you to find 3 points? Make sure it's a line, and it serves as a check in case we made a mistake. Personal opinion, I don't think it's very likely that I'm going to make a mistake going x is 4, or y is 4, x is 5. I don't think I'm very likely to do that. to me, 2 points here is enough to make a line. Where is 0, 4? Which way 4 for 0, 4? That is up 4. Where is 5, 0? Right, 5. And then I just connect those with a straight line. If I wanted to find a third point to check, could I? Yeah. But I don't think it's necessary. I feel pretty confident that I just did the right thing on that. Question there? I would not immediately do intercepts probably on this one. Why might I not immediately do intercepts on this one? It's not in standard form. Could it be made to be in standard form? Yeah. And if I do, will the stuff divide the way I like? Yeah. So I would do that. I'd leave the 2x. When the 5y flips sides, it would be minus. When the 10 flips sides, it's a negative as well. And now I can find intercepts. If x is 0, cover up the xiness with my hand if I wanted to. Do an opposite. Y would be, if the x disappears, and we solve that, y wouldn't be negative 2. It would be a positive 2. Where is that? Up 2. If I make the y 0, what would the x be? Negative 5. Where is that located? Left 5. And place some connected offs. Something about that. Am I saying doing this intercepts thing will work every time? No, I'm saying sometimes. Sometimes it's a quicker way to go. If you wanted to make a table, you can make a table all you want. This one, it's not in standard form. I could get it in standard form. I'm not going to bother. Why would I not even bother trying to get this in standard form or do intercepts? Yeah, it is, and it's also, what can't it do that those other ones were doing real nice? The dividing. Like you'd be dividing with fractions, that's just going to be a mess. Someday we'll graph this using slope-intercept form. If you remember how to do that already, go ahead and do it. But for now, I'm not going to get into that. I'm going to save that for another day. I would just build myself a table. So since it's y equals, I'm going to pick my 0, 1, 2 kinds of numbers for which of them? The x. If it's y equals, we pick for x. I would do 0 for sure, always. Would I do 1? I wouldn't, because if I do 1, I'm going to have left a bunch of fractions. Who's going to help me multiply and not get fractions? 2 and 4. So anything times 0 and then minus 2. Negative 2. Where is 0, negative 2? Down 2. If I do 3 halves times 2, the 2's are going to cancel. So 3 left standing minus 2 is 1. Where is 2, 1? Write 2 up 1. 4, when 4 would cancel 2, the 4 turns into the 2 times the 3 minus the other 2, 4. Where's 4, 4? Write 4 up 4. And on graph paper, this would look even better than mine is, but this is pretty good. That's pretty straight. Nice straight old line. That would take your homework up to 42. I have one more section to do to get us up to 54, so we'll have to stroll to the left. Question before we take the stroll. All right. Okay, so pleasant surprise for you, I think. Usually the hardest thing is last. Today, I think the easiest thing is last. So if I drop you an x equals line or a y equals line, those are the easiest kinds of lines to graph. Does anybody have a memory of how the x equals lines, y equals lines went? Some of them were vertical, some of them were horizontal. It's just a question of which was which. Which way did you think? That's correct. All x equals lines are vertical. All y equals lines are horizontal. If vocabulary isn't your thing, which is which?
Horizon is like the one that's it's like a horizon for it.
Yeah, so horizontal is like the horizon, like where you see the sunset, go this way. Vertical is up and down, like vertical jumps for basketball or whatever you know about verticality. Reason being, so let's graph this and then I'll tell you why this works. If we want to find where x equals 3's line is, somebody, can you get me x equals 3, where does that live?
It's like right three.
We're going to go right 3 squares and then do a vertical line. This would be the line x equals 3. Because what we're trying to do here is all the ordered pairs where x is 3. For example, 3, 1, and 3, and all that stuff. Okay, so like 3, 1 is there, 3, 2 is there, 3, 3 is there, 3, 4 is there. We don't need to sit there and list them all. If we go to where x is 3 and just stay there, we're going to go up, we're going to go down, we're going to have all different y's. But for x to stay 3, once we get over 3, it has to be a vertical line. So a y of 4, where would you suppose? Go up 4. And once you're there, just go horizontal. You've got to just stay there. That would be the line y equals 4. So if I go x equals -1, left 1, go vertical line, x equals -1, and then the last one, a y of -2, go down 2, and go horizontal line. You could probably do like 20 of those on one coordinate system. Okay, so when you get to the 43 to 54 section, all of those could probably go on the same graph area. Just label them with their titles or label it like this is number 1, this is number 2, this is number 3. As long as you somehow have them labeled, you should be able to do that almost endlessly on the same XY axis. The only thing that's difficult at all about that last group is on some of them, they don't say y equals 4, they say like 5y plus 2 equals 20. And then you've got to solve. So in other words, 5y, let me make this divide better, 22. So 5y would equal 20, so y would equal 4, and then you just graph the line that we already did. But on a couple of those, you'll have to do a little bit of oppositeness to solve to get the variable alone on that zone. If you want to peek at 128, again, I'll do a reverse run back through. The last group of homework is just x equals lines to be vertical, y equals lines to be horizontal. The previous group, 42 back to 33, really is the same as the group before that, from 21 to 32. I'm going to tell you on those two groups, completely ignore the directions. The one direction set is telling you to use intercepts. The other direction group is not telling you to do that. I'm going to say do what you want. So there's two groups of homework that go from 21 to 42. If you like the looks of intercepts, do intercepts regardless of what the directions say. If you don't like the looks of intercepts, do a table regardless of what the directions say. So you graph those however you want to graph those from 21 to 42, table or intercepts, you decide. The group before that on the homework is just writing stuff in standard form, which will do what I'm saying, x and y to a side, the number out of there. And then the first group is a yes, no, is it linear? Anybody see anything on the 127 spills into 128 that gives you any sort of concern?
You good on the 33 and 42 group?
33, the 21 to 32 group, just keep doing it on the 33 to 42 group. If you like using intercepts, use them. If you want to make a table, make it. You do the same thing. They're in book directions, when you get to 33, they say you have to do intercepts. I'm saying no. Do intercepts when you want to do intercepts, make a table when you want to make a table. We're not going to listen to what they have to say. Is that okay? Good. Anybody? Yeah, it's like the three we did over there. If I wanted to do the intercepts, I did. If I couldn't do the intercepts, I didn't. I did what I wanted to, either table or intercepts. You can pick for each problem what to do. You don't have to listen to them. The one group, they said, like, you have to do intercepts. So the one that I made the table, if I had to do intercepts, like I could have, but I don't want to, it's hard. Anything else, anybody, I can do anything to help you feel better about 127, what you're looking at? All right, that's it.